So I think we'll just get started here. And again, thank you for attending the webinar today. We're going to be going over how to do regression analysis in FCS Express. It's one of our new and exciting features that we've added. So in FCS Express, we now offer the capability to create scatter plots and custom regression analysis directly in the software. This means that you don't have to export to Excel anymore to do these type of things. Excel, Prism, GraphPad, whatever your plotting program of choice is at this point. And you can also now see your scatter plots and trend lines update in real time in response to gating changes or when changing data files within a template. And there's many fits available in FCS Express, so there's probably one for you. And you can extract any of the fit parameters within the software to record or use as tokens further on down the line in your analysis. This can be done with any of your flow or imaging data. And we have many resources and in-depth explanations for regression analysis in our manual and in our tutorials. And I just want to bring up our web page here real fast, which I have on my other screen. Here's our home page, and I just wanted to show you where these resources are before we start. You can find these in support and either in our manual page here or in the tutorial section. You can see down here that we have the online version of the manual and the online version of the tutorials. And here is the front page for one of our tutorials. You'll see in the bottom we have this linear regression analysis tutorial. At any time you can come back to this tutorial. We provide sample data, and this will give you a good starting place for creating regression analysis on your own. This doesn't necessarily have to be linear regression analysis. You can put in any type of fit that you want when you get to that point. And speaking of all the fits that we have available, I just want to show you in our manual page we have an available equation section here. This is located in custom data, regression analysis, and available equations. So here on this page you're going to see what the typical equation name is, the function name in FCS Express, which I'll come back to once we start working with these, and the actual equation that we're using to derive the fit parameters and the variables that you can extract within FCS Express. So you can see here we have just about every fit equation that you would probably ever want to use in your data. If there's something here or if there's a fit equation that's missing that you'd like to see, just send us an email to support@denovosoftware.com and we can try and put that equation in for you in the next update of FCS Express. So the first thing that I want to do today is bring you through a few example layouts. And then we're going to show you how to create your own custom regression analysis. So the example layouts are just going to give you an idea of some of the things that you can do within the software. And anything that you see in the create your own example can be applied, and you can get regression analysis that way. I also want to add a note here that this webinar is going to build upon your prior knowledge of, I guess, the basics in FCS Express. So we're not going to go over how to create gates, how to create custom data, and how to insert bar and scatter plots and all that. If you're not yet familiar with these features, please see our Getting Started in FCS Express and are using custom data that are located or recorded webinars, that are located on our website. These can be found down here off the main page. There's a lot of resources here for you to get up and running with the software to get you to the point where you can be starting to do regression analysis. So let me bring up the first example that I want to show you today. We're going to start from a kind of basic type type of regression analysis. Actually, this isn't really a regression analysis. This is more of a scatter plot where we've connected the lines. So this is probably the most basic thing that you can do with scatter plots. You can see here we've inserted a scatter plot. We have our custom data for that scatter plot, and we're plotting % live versus % apoptotic cells. We've plotted these as triangles on the graph, and in our format options here, if I come to format and overlays, you see that we have an option to connect the points, and that's right here. So let me move this over to the side, and I'll just show you if I uncheck that button and click preview, we've just unconnected the points. So this is the most basic way that you can create some sort of trending of your data within the software. The nice thing about any of these scatter plots is that as I move this gate, you'll notice I grab the apoptotic gate on the left, that they're going to update in real time, right? So when you have a change that needs to be made to one of your gates, and say you've already set up your analysis in Excel, at some point you'd probably have to re-export that data if you need to shift your gate around, and then recreate that scatter plot. So FCS Express is going to allow you to do this in a more seamless fashion. And you'll also notice that our slope here, our M value, is actually being calculated by a custom token, and it's just using the equation for the line here that's coming from a bunch of different statistical parameters within FCS Express. So this is flow data that you're seeing right now. I also want to point out that these values in the custom data grid, they don't have to be tokens that live update. If you want, you can see here for the sample ID, which is just another parameter that we could put in, you can just manually enter numbers in this custom data grid. So if you choose not to do tokens, that's fine. I highly suggest that you do use tokens, since you're going to get the most out of the software that way. Now I'm going to take you to a more advanced type of regression analysis here, where we're actually overlaying trend lines. This is from a experiment done on the Molecular Devices Isocyte or Velos machine. You can see here, here's the high content imager. This machine allows you to acquire plate-based data very, very quickly. And this is plate-based imaging data that we're actually looking at here. We didn't choose to load the images, we just chose to load the dot plots for all of these at this point. But to get an idea of how this is working, you can see that we have a bunch of scatter plots opened up, and I've inserted a token for the title to be the name of the gate that this is gated on. So in this scatter plot, the gate here is gated on wells BC from column 1. So if I actually edit my gate for BC01, you can see that here's where the data is coming from, and here is the data from those two wells. We've also set up a gate to measure the % positive cells that fall within each of those gates or each of those plots, and we've done that across the rows here for all 12 rows. And what that does is allows us to create a custom data grid, and since we have a known concentration for this assay that we've manually entered in this case, you can see that these values aren't grayed out in this custom data grid, so that we've manually entered them. But we have the % positive token being displayed here, and let me bring this somewhere else on the screen so you can see it a little better. But this % positive token actually relates back to the plot, and you can see here that this is 6.94%, and that's where this token is being displayed. And since these are tokens, and you can see we have our IC50 curve here, when I actually change this gate, our IC50 or 4LPL fit in this case is going to update in real time, and that goes for the trend line overlay and it also goes for the plots or the points in the scatter plot itself. So here's an example of just creating one overlay, and let me go back to our kind of report page at the end here. And since the gates for these three compounds and these three rows or 6 rows in the plate are all linked, this means that in our final report here, it's all based on this one gate. So when I move the gate, obviously this gating strategy doesn't make much sense because our curves went way off the screen. But if I move the gate and say move it to the right here, you can see our 4 LPL fits are updating in real time. And I also want to draw your attention to this table that we set up here. Now, in the table, we've actually extracted values from the fit parameters within the software for the minimum and the maximum of the IC50 curves and the IC50 value itself. And again, since these are tokens, notice that these values are updating in real time as well. So not only can we have these scatter plots update, but we can have all the statistics update in real time. And that way, if you come back with another plate-based assay and you load a new plate into here, that all the regression analysis is going to update. You don't have to recreate all the analysis in a new table or anything. You can just iterate over your plates, or if you're just dealing with individual samples, you can iterate over those, and all of your statistics and plots are going to update in real time. So let me take you to another example here, and this example is where what we're going to be recreating within the software today. And this is a CD64 antibody titration curve. You can see here that we have the amount of antibody added versus a parameter, which if I do a 2-page view here, this parameter on the y-axis here is actually coming from the FL8 log. This is the parameter that we're interested in plotting here. And the idea behind this assay and this curve is that we want to find the amount of antibody to use in this titration curve that's going to give us 90% of maximum binding. So we've inserted some custom tokens here, the Vmax, the 90% of the Vmax, and then we've also created a custom token for the amount of antibody to use. And you'll notice that it's green because it relates to this green dot on the plot. And as I move my gates, if I shrink my monos gate, the titration overlay, all the points are going to change, and this amount of antibody is going to change as well. All right. Another nice thing to notice about this plot is that our concentrations are actually stored as keywords here. So what we're going to do today is now we're going to recreate this analysis to show you how to use or how to set up custom regressions in FCS Express. And I have a basic starting point here with our gates set up. And you can see on the second page here we have all of our plots. So let's just go right ahead here. And the first thing that we're going to want to do when creating a regression analysis is insert a custom data table. And we can do that from the Data tab, Custom Data, and we'll enter a new custom data. And let's call this raw titration data. And this is going to set up our scatter plot. So what we want to do is have 2 columns, one for the concentration, one for the amount of antibody added. And I believe there's 7 samples. So we'll click OK. And now we can go to our View tab. And in our Data Navigator here, you'll notice that we have the custom data for this raw titration, or the custom data grid here for this raw titration data. And we'll just drag and drop this into the layout and choose a data grid, and here's our data grid that we can start with. So let me rename these columns by right-clicking, choosing Rename Selected Column, and we'll use concentration of antibody for the first column, and we'll rename this column to mean value, and click OK. And now all we're going to want to do here is start filling up this data grid. And to do that, I'm going to use a 2-page view here. And we'll go to the second page. And as I noted that all of these concentration values are stored as keywords, that means all I have to do is drag this plot in here, choose a keyword token, and click OK. And the keyword that we want to use is located all the way down on the bottom here. And let's navigate to this real quickly. And here it is, concentration. So we've actually stored this value with the data. We'll click OK, and OK again. And now we have the concentration for the first sample. What I'm going to do now is just copy that, and I'm going to paste that token into the rest of the boxes in this data grid. I find this to be the easiest way to do this. And what I'll do is I'll just double click on this value, on this keyword, and I'm just going to choose the next concentration or the next sample from our data source. And when I do that, you'll see that the concentration changed to the next value. So I'm going to do that for these next samples here, so we can generate this antibody concentration titration. Just choosing the samples, changing the samples to get the right keywords for them. Let's see here, we're on 5 microliter, and let's see, we'll go to, let's do this 5 microliter again here. I made a mistake, so we'll just come back and choose 2.5 microliters, and our last value for the concentration is 10 microliters. Alright, so just like that, we've inserted all of our custom tokens for the concentration, or our keyword tokens, and now we want to enter the mean value for the y-axis. And again, we can just do this by dragging and dropping into the custom data. This time we'll use a statistic token, and let's choose the monos gate, and we'll choose the y geometric mean. And now we have the y geometric mean for the 0.156 microliter plot. And again, I'm just going to copy and paste this token into the rest of the data grid, into the custom data, I should say. And we'll just change these samples quickly to the correct plot, and that's going to give us our titration curve here once we're done doing this. So just bear with me for one moment while I complete the custom data table here. Alright, so we'll choose the last sample, 10 microliters. So now we have our custom data table ready, and we can go back to our one-page view. Since everything's based on tokens, we probably won't have to go back to that second page. And what we can do now is insert a scatter plot. So let's choose this data grid. You can see it's highlighted in red, and we'll insert a scatter plot, and that's going to insert a scatter plot for that data. You can see now we're plotting the mean value versus the concentration of the antibody, and probably the first thing that we're going to want to do with this scatter plot is just format it a little bit to make everything look a little bit nicer. We'll change the point size to, say, let's go 4, maybe that's a little too big, just so we can see the points a little bit better. And let's change our axis values here as well, so that we can see everything on the correct scale. And now we're looking at a replicate of the antibody titration curve that we saw on the last page. So at this point, we've plotted the data. What we want to do is get the fit parameters out of this. We want to know what the equation for the line plotted in this is. To do that, we're going to insert a custom token. So we can go to View and Custom Tokens, and let's move this to the side. And since this is an antibody binding assay, we're going to use the Michaelis-Menten equation, and we'll call this Michaelis-Menten fit equation for our custom token name. And if this was a linear equation, you could type in linear fit equation, whatever you'd like. And in this custom token, we'll enter equals, and if we right click, we have the option to insert function. And this is where you can access all of your regression fits and extracting of the fit parameters. And what I want to do is I'm going to hit the P button here, so it's going to bring me down to the P section of the list. And here are all of our perform Boltzmann fit, perform cubic fit, exponential, all of this. What we want to do is perform a Michaelis-Menten fit. So we're going to choose that, and if you're doing a different type of fit, you would choose that fit. And now we're going to be prompted with a fit equation that's going to ask us to insert our x values and y values. So I'm just going to highlight our x values. I'm going to right click and choose insert token. So the token that we want to insert now actually comes from a data parameter, and that data parameter is based on this custom data that we had set up. So let me click insert for the data parameter, and we'll choose custom data. You can see here is our raw titration data, and the parameter that we want to use, the x value, is the concentration of the antibody. Okay? So we're just going to do the same thing for the y values, and we're going to insert a token, again a data parameter. We're going to choose a custom data, our raw titration data, and the parameter that we want to use for our y values are actually the mean value this time. Now you can notice here our token is actually highlighted in pink. That means that it's a text value. So if we just double click on this again, we want to change this to a numeric value. Alright, and now you can see it's going to be highlighted in blue. So let me do that for this again. So now we have the x and y parameters. For this particular assay, we don't have any fixed parameters, so I'm just going to delete that. And we don't want to put in any standard deviation values for this fit. And there we go. We have our perform Michaelis-Menten fit. And when I actually take this custom token and drag it out onto the layout anywhere, you can see now here are our fit parameters. Our Vmax is at 769. Our K is at 1.56. And we have a R squared value of 0.96. So it's a pretty good fit for the curve, right? So this is great if you just want to get, some fit parameters from this, but what we really want to do here is insert a trend line overlay. And the way that we're going to do this is that we're actually going to create a new custom data, and we're going to automatically insert x values for this curve, and then we're going to convert those x values to y values based on the fit parameters. So let me show you how we're going to do this. You can see here that our first x value is starting at 0.156 and our last is going to 10. So for our overlay, we probably want to create a trend line that maybe starts at 0.1, so it falls a little bit before this 0.156, and let's end it at 12. So that way our trend line overlay will go a little bit further than our highest value. So to do this, let's insert a new custom data, and we'll call this Michaelis-Menten regression overlay. We're going to do 2 columns because we want one column for concentration or x and one column for mean or y. And then since we want to go from 0.1 to 12, and we want to do that in, say, 0.1 increments, we're going to insert 120 rows into this custom data here. And let's open the data grid after we create this. Alright. And now we have this blank data grid. And what we want to do is fill this with first, I guess, x values from 0.1 to 12 in increments of 0.1. So to do this, let's do what we call parameter math in the software, so we don't have to fill this table in by ourselves. That'd be grueling and boring. So I'm going to do a single calculation with my parameter math, and you can see that my data grid is, or custom data is selected. And we want to use the A parameter for this. And the formula that we want to use is equals, and we're going to use 1 divided by 10, because that's the value for 0.1, right? And that's going to be our starting point. And we're going to add this to row minus 1. And what that's going to do, it's going to say we're going to look at the row before us, and then add this new value to that row. And the new value that we're going to use, we're going to times this by 1 divided by 10 again. So pretty much what's going on here, it's saying that start at 0.1. For every row, add a value of 0.1 from the last row. All right, and we'll leave this evaluate tokens before adding the data checked, and we hit calculate. You'll see in our custom data that we've now calculated 0.1, 0.2, and this is going to go all the way through our data list down to the end here. So let me make this custom data a little bit smaller so we can see everything that's in here. But the idea is we're going from 0.1 to 12 in increments of 0.1. So what we can do now is we can use our parameter math again to calculate all of the y values for these based on the x value that's there. So to do that, let's insert a new output parameter for column B. And the formula that we want to use this time is actually going to be a function. So we're going to insert equals, and we'll insert a function. And if I go down to M here, because we're doing Michaelis-Menten fit, you can see that we can use Michaelis-Menten. Let's convert x to y, and let me just insert here. We can convert x to y, and we insert the x value, and then the model parameters, or the fit equation that we already defined. So the x value is actually going to be column A, and in this case that's called parameter 1, so we're going to enter P1. And the model parameters for this, if I highlight that and right click, let's insert a token, it's actually going to be our Michaelis-Menten fit equation, because here's the model parameters from that custom token. I'm going to click insert, and I don't want to evaluate these tokens before adding to the data, so I'm going to uncheck this, and when I click calculate, you can see that our y values are automatically calculated. So this could be useful for a whole number of things besides creating overlays. But now I have a whole list of x values and the corresponding y values based on my fit curve. And what that's going to allow me to do is just drag this entire data list onto our scatter plot. Let's add this as a new overlay. And you can see that now we have our Michaelis-Menten trend line appearing on top of our scatter plot. And let's make this scatter plot a little bit bigger so we can see everything. And at this point we are displaying that fit as dots. Probably what we want to do is come into this plot by right-clicking and formatting. And we can go into our overlays here, and now you can see we have our raw titration data and our Michaelis-Menten regression overlay. So let's choose the overlay. Let's connect the points, and since we don't actually want to view the points, we'll change them to white. And you can also see that we have an option for our connecting lines here, right? So let's change that to from black to red. And when I click preview here, you can see that we've removed the points, we've turned the points white so you can't see them, we've connected them, and we've turned the line red. So let me click OK. And now at this point, anytime you move your gate, our scatter plot is going, or our scatter plotting points are going to update, and our trend line is going to update. And you'll notice that in our custom data here that all the y values are updating because our fit parameters are changing as we move this custom data move this gate, which is going to change our fit parameters here. So that's how we create custom regression overlays within the software. What we can now do that we have this is we can probably what we want to do is extract some useful values from that rather than just seeing the trend line and the curve. So since this is an antibody binding assay, what we want to do is find out where 90% of the Vmax is, or 90% of the mean value is, and then we want to associate that with the concentration of antibody used. So we're just going to use a custom token here again. So let me enter another custom token, and we'll call this Vmax. And what we're going to use now is a function to extract parameters from the fit custom token that we defined. So let's extract here Michaelis-Menten results. You can see here, I click on it, we're prompted again here. The model parameters are the custom token that we defined as the Michaelis-Menten fit parameter. So let's insert that custom token. And there's our fit equation. And the value that we want is just this Vm. So what I'm going to do is delete everything else in here. And now what we're going to do is say, look at this equation that's down here and give me the Vm or the Vmax of that equation. So when I drag this Vmax out, and I had to put an equal sign before this, I should remember that, we now have the Vmax of our custom regression analysis, and it's in a text box, so we can say we can just type in Vmax equals 929, and let's put this over here on our layout. Alright, the next thing that we probably want to do is calculate 90% of that Vmax. So to do that, we can just enter a new custom token and call this 90% of Vmax. And this formula is actually just going to equal this token, so I'm going to highlight it and drag it into my custom tokens here and say times 0.9, and when I do that I should be able to drag this out into my box here, and let's make sure that this value is correct. And since I entered custom token, the Vmax times 0.9, here's our 90% value, and we can say 90% of Vmax equals 836. And again, I just want to draw attention when I update these gates that these values are updating in real time as well. So we're calculating all of this on the fly. So now that we have this 90% of Vmax, we can just back calculate doing a y to x conversion to get the amount of antibody needed at 90% Vmax. So we'll do that again by coming into our custom tokens over here, and let's add a new one, and this is amount of antibody to use. And we can, let's see here, we can hit equals, and this time we want to insert one more function, and this is going to be our Michaelis-Menten, and this time let's go y to x. Since our y value is this 90% of Vmax, we can just highlight the y value, insert a token, use 90% of Vmax, and the model parameters that we're going to use are again going to be this Michaelis-Menten fit equation that we defined already, and we'll click insert. And now we have our new amount of antibody to use custom token, and let's put it in our text box. We can say amount of antibody to use equals, let's make this text box a little bit larger now. And now you can see that as we're going to move our scatter plot or update our plot here, that all these values are going to update in real time, right? So this is very nice, and at any time we can find out very easily what our amount of antibody is to use. Since our Vmax is a little high here, let's actually change the y-axis to be automatic, and then we're gonna, as we actually move this gate, our y-axis will update. And one other thing that you may want to do is actually plot this value like we did on the example as a green dot. And to do that, we can just, again, insert custom data really quickly. We can call this amount of antibody to use overlay. And in this case, we're only interested in one row and two columns. The columns are going to be for the 90% of Vmax and the amount of antibody to use. Let's open that data grid. Here we see it opened at the top. And let's bring it over here. And we'll adjust our text box a little bit. So our y value here, or our x value, is going to be amount of antibody. And our y value, I'm going to rename this column, is going to be 90% of Vmax. And all we have to do here is just highlight and drag and drop our tokens in here. And let's do this in a way that we'll just copy and paste them. And now we have this new custom data. We can just drag this onto our scatter plot and add it as a new overlay. And you can see here it's a very, very tiny blue dot. So that's of no use to us, right? We want to be able to really see what that amount is. So let's come to this amount of antibody to use. Let's make this point color bright green. Let's make the point size something large so we can see it, and click preview. And we'll click OK. So there's our amount of antibody to use plotted along the regression overlay or trend line, along with all of our raw data. And all of these, again, are going to be updating in real time. So as I shrink this monos gate to be something a little more reasonable, you can see that everything is updating, shifting in real time. All right. So the nice thing about this, we can do all of these regressions in the software, have them update in real time. As you see, there's a little bit of upfront time that has to be put into setting these things up. But once you have defined this layout, we can save this layout, and we'll just save this. It opened up on the other side. And when you have new data to load into here, since all of our concentration values are stored as keywords, all of our mean values are stored as tokens, when we actually update the data, and we do this experiment next week or a similar experiment to it, we bring in all the new data, all of your regression analysis is going to update with that new data. So once you've defined this kind of layout once, it's set, it's done, and you can bring in your new data. All of it's going to update automatically, and when you're ready to publish this or do whatever it is that you want, collaborate with your colleagues, we can, as always, just go out to Microsoft PowerPoint. We can go to Microsoft Excel. We have some functionality in Microsoft Word as well, and PowerPoint is opening up now. And here's our final report. You can see that we have everything in here. We know how much antibody to use. We can print this out, give it to our lab tech, whatever it is you may want to do with that. So at this point, I kind of want to open up the webinar to questions as we're coming to the end here, and I'll bring up our summary as well. So if you have any questions, please type them into the box, into your questions box, and I'll just go over the summary real quickly while you're asking questions if you have any. But FCS Express, as you can see, it leverages some of the most powerful and proven tools in flow cytometry, and we have new features like this regression analysis to improve your analysis and improve your workflow. We're going to allow you to bypass the step from going out to Prism or Excel to do your analysis. All of this is combined with state-of-the-art visualization, plotting, graphing, report generation in one package, so you don't have to have a whole bunch of packages now to go out to Photoshop or PowerPoint to change the way your plots look, go out to Excel to analyze them, and then have another piece of software to actually do the flow or image analysis. It's all within the software. Our Microsoft PowerPoint-like interface makes the software easy to use and understand. You can also notice that our custom data grids act very much like an Excel spreadsheet does. So if you've ever used Excel, you've used formulas in Excel, or if you use PowerPoint, I think you should be able to do this type of analysis relatively easily. We also have many resources for our customers, like the tutorials, sample data, an online forum, and really good customer support. So if you have any questions about regression analysis, you can access the linear regression tutorial to really bring you through it step by step and at a much slower pace, at your own pace, rather than rushing along with the webinar here. Or if you run into any roadblocks or any kind of problems, just email us at support@denovosoftware.com, and we'd be happy to get back to you and give you a hand with your analysis or answer any questions that you may have. If you haven't already, you can get our free 30-day trial at denovosoftware.com, and then you can come in and try all of this regression analysis for yourself. We are also recording this webinar, so it's going to be available on our website, again at the recorded webinars right off of the front page. So if you'd like to check back in a few days, you can download this webinar so you can maybe slow it down a little bit, go through step by step, make sure you understand the process of creating these regressions. So at this point, I don't see that any questions have come through. So I hope you enjoyed the webinar today. I hope that everybody found it useful and that you'll be able to get up and running and creating your own regression analysis within FCS Express in a short amount of time.